for this video, we're going to be looking at using patterns and inductive reasoning. So patterns and inductive reasoning. Reasoning. All right, this is the thing I love about geometry. Geometry has so many patterns and things that you have to see. So it kind of challenges our brains because it gives you problems to look at and try to devise. So before I even get into teaching you guys, let me do this for you. Let's say you have a triangle. All right, a triangle here. Let's see, 1, 2, 3, 4, 5. All right. Now, each of these rows have an amount of triangles. Oh, that's terrible. That should be over there. Okay, and every time you add a row, obviously, the number of triangles expand. So, knowing this, right, so this is 5 rows on the triangle. Don't judge my art, I know, it's not great. All right, so this is row 1. 1, 2, 3, 4, 5. Now before I even go any further, if I was to add 4 more rows to the bottom, how many triangles will I have? Okay, so go ahead and work on that yourself. Okay, you should be looking for any patterns. Okay, this is row 1, row 2, row 3, row 4. So if you add 4 more, you should be over to row, what is it, 6, 7, 8, 9, 10. Or 10, one of those two. So figure out how many triangles you have. Okay, these are the type of problems you'll be doing in geometry. All right, using patterns, seeing what you see to try and solve a problem. Now, vocabulary words. What is inductive reasoning? Inductive reasoning is a type of reasoning that allows you to reach conclusions based on a pattern of specific examples or past events. There's a lot to write. Oof. All right. So is a type of reasoning that allows you to reach conclusions based on a pattern of specific examples. I'm sorry if you can hear that. My wife is watching Grey's Anatomy in the background, and you might be able to hear it from on my microphone. So inductive reasoning is a type of reasoning that allows you to reach conclusions based on the pattern of a pattern of specific examples or any past event, really. All right. So when we're using inductive reasoning, okay, this is using, you're seeing any patterns. Like for example, if you have 2, 4, 6, and 8, what do you think the next numbers are going to be? The next 3 numbers, okay? 10, 12, 14, right? You use the past to decide the future. Okay, the past examples decide the future. You use your inductive reasoning, your brain, your knowledge in order to help you do so. Okay? If I was, for example, if I had a pattern of numbers, let's say it was 5, 10, 15, and 20. What's the next three terms? It's going to be 25, 30, and 35, right? You use the past to decide the future. The other thing is conjecture. Conjecture. Goodness gracious, that was hard. All right, this is a conclusion that's reached by using inductive reasoning. So a conclusion reached by using inductive reasoning. So a conclusion reached by inductive reasoning, okay, that is what we consider a conjecture. Okay, this might be in shapes, this could be in word problems, months, whatever it may be. All right, let me give you this problem. All right, if 6 points on a circle are joined by as many segments as possible, how many non-overlapping regions will the segments determine? You have a very nice circle here. Well, I guess it's more of an oval, huh? Meh. Meh. Oh, here we go. This is more even. Okay, now these are all connected to each other. This point goes here, 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 here. This point will then connect to all these points. But not this point because it's already got a line there. Same thing as this one. There's a line there, there's a line there. So we're going to connect to this guy, this guy, this guy. This guy's connected to him, 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 or her, I guess. So let's go to them and them. And this guy, or girl, has been connected to all these guys, or girls, except for this one. There we go. There's all of our spaces. Now, we have 6 different points. All right, we could sit here and we could count, right? We could count all the spaces that are in the gaps, right? All the, this is 1, 2, right? 1, 2, 3, 4, 5, 6. Well, that's kind of annoying, okay? So if we're trying to figure this out, let's do this an easier way. Let's start back at 1. There's a circle. Okay, let's start with 2 points, 2 segments. 1, 2. Or sorry, 2 points, 1 segment. All right. So we got 1 and 2 spaces. So at 2 points, we have 2 regions. Cool. Let's do 2. Or I guess it'd be 3. 1, 2, 3. All right. Boop. 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 Now I got this nifty little triangle. We got 1, 2, 3, 4. So at 3 points, we have 4 regions. All right. I mean, we probably could have counted everything by now, but let's say you wanted to go higher and higher, okay? There comes a point at which you don't want to count. Let's say we wanted to put 10 points on the circle. How many regions do you have? Okay, this is where works out well to put the numbers down. Let's go 4 points. 1, 2, 3, 4. So we got connect, 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 boop, boop, boop. This is 1, 2, 3, 4, 5, 6, 7, 8. So at 4 points, there are 8. Okay, do you see a pattern yet? You see it? you see it? So what do we have to do here to get to there? Add 2. What about from here to here? Add 4. Okay. Or another way to look at it, you double each time. Okay. So if you're doubling each time, we don't even have to draw the next ones. 5 would be 16, 6 would be 32, 7 would be 64, and so on and so forth. See, once you figure out the pattern, it's much easier to keep it going. Okay, so if I asked you a really dumb question like, well, if you were to put 10 things on there, what would it be? Well, you'd sit here and you'd go, 8 would be 128, 9 is 256, and 10 would be 400, 512. Okay, 512 regions. Instead of having to sit there and go like this. 1, 2, 3, 4. Okay, you were able to get there in way less time. Okay, so use your inductive reasoning, use your brain, look for the patterns. Okay, don't sit there and try and count. If you go back to that first problem, right, with the triangles, if you made 4 new rows and then counted them all out, bravo. Well done. I would not have done that. I would have sat there and I would have seen that row 1 equals 1 triangle. 2 equaled 3 triangles. 3 equaled 5 triangles. 4 equaled 7 triangles. 5 equaled 9 triangles. So if we added 4 more rows, that would be 6, 7, 8, 9. Okay, what's the difference here? We're going up by 2. So you got 11, 13, 15, 17. Now, I asked how many triangles you had total. So you'd have to add these all up. Or whatever. We'll take this weirdly. I guess 5 plus 7 is 12. 20, 28, and 17. Or I could just add them up like this. 4, 6, 0, 8 is 14, plus 7 is 21. Boop. 1, 2, 3, 4, 5, 6, 7. 71. Nope. 81, because that was 21, not 11. 81. So you should have gotten 81 total triangles. Alright? So look for the patterns. They save your lives. Okay, bye.